So today we're getting into factoring, multiplying binomials. So 2.4 notes will be split into two. So we have 2.4a today. So just a refresher, when you're multiplying binomials, and again, what's binomial? Well, bi means two, so two terms. When we're multiplying binomials, we're going to use what we call FOIL, the distributive property, or the box method. Technically, it's all distributive property, it's just different ways to do it. So again, remember, FOIL means first terms, outside terms, inside, and last. When I mean box method is when you have a box like this, and let's say you had x plus 3 and x plus 2, right? And you had like x squared, 3x, that's the box method, right? So you might have saw that depending on who your math 2 teacher was. So when we're multiplying two binomials, we're usually almost always going to get a trinomial. So understand that, because a lot of students forget the middle term, the b term. So we're going to multiply. So I'm going to use FOIL. So first terms, x times x is x squared. All right, now the O, outside, so x, right, our outside terms, so x times negative 3 is negative 3x. Now we're going to use our inside terms, so that would be plus 8x. And now we're going to use our last terms, which is negative 24. And if you do this correctly, every single time, those should be like terms that you can combine. It's just sometimes they might combine to 0. In this case, they don't. So I have x squared, right? Combine my like terms, so plus 5x minus 24. So I had two binomials, they multiply to give me a trinomial. Again, trinomial means 3 terms, binomial means 2 terms, monomial is 1 term. And we'll get to polynomials later in the year. So that's using FOIL. That's the method that I'm sure most of you are familiar with. Now, I'm going to use the distributive property, which is really FOIL, it just doesn't have a fancy name for it. So I'm going to do 3x times x is 3x squared. Then 3x times negative 5 is negative 15x. Okay, now I'm going to distribute the 2. So you get plus 2x, and you get minus 10. Literally just did FOIL, just with not calling it FOIL. Again, like terms, combine those, negative 13x minus 10. Binomial multiplies to a trinomial. That almost always happens. If you can remember that, it makes it a little easier. Again, why we're going over this, because we're going to get into factoring. And really the way that you check your factoring is with multiplication. Okay, so when we're factoring, we want to first look at the number of terms. So what do I mean by terms? Like, for example, 4x squared is a term. Right? The number of terms is going to help us determine the method. Right? Sometimes you're not going to be able to factor it, but most of the time you will be. But you always want to start by looking for a GCF, a greatest common factor. Why? Because it makes the factoring easier, because you usually get smaller values, smaller constants, smaller variables. So, no matter how many terms you have, first thing we're going to try is a GCF. So I look for a common factor, right? What do they have in common? Sometimes it's a number, sometimes it might be a variable, sometimes it might be a combination of both. So in this case, right, they share a 2 and an x. So I can factor out a 2x. So what would be left? So if you factored out a 2x, what would be left in the first term? Well, that would be a 2 and an x. What would be left in the last term? Well, that would just be a 1. So if you quickly check this, if you were to distribute this back through, would you get what you started with? Well, if you multiplied, you would get 4x squared minus 2x. So this would be factored. So as we go through and factor, realistically, you should be able to tell me if it's right because you can multiply it back. So the difference of two squares. So if you have two terms, right, that means there's a minus sign. What is a perfect square? What's the difference of a square? Right, a perfect square is 1, right, 4, 9, 16, right, 25, right, 49, and so forth. Those are perfect squares. So we're looking for a difference of perfect squares. So 4x squared and 9y squared, those are both perfect squares. So that means it's going to factor into two binomials. One's plus, one's minus. They're going to be identical. Whatever you write in the first group is identical to the second group other than the signs. So what number do you square to get 4? 2. What do you square to get x squared? X. What do you square to get 9? 3. And y squared would be y. So that's what it factors into, a difference of squares. So when you see that, automatically, two grouping symbols, one's plus, one's minus. The first one and the second should be identical. The same values you put in the first go in the second. Okay, if you have three terms, right, now we're going to be doing trinomial factoring. So some of you, depending on your hand, that might be a box. Could be like a diamond method, guess and check. Right, whatever you need to do to factor this. So I know it's going to be two binomials. Okay. So I need the factors of 40. So 1 and 40, 2 and 20, 4 and 10, 5 and 8. Okay. Also, is there a GCF? When you're looking at that trinomial, is there a GCF? Well, the only number that goes into 6, 1, and 40 would be 1. So yeah, there is 1. That doesn't help us. Okay. So knowing that, I can eliminate some of these choices. Well, so for example, how do I know 2 and 20 will not work? Because they have a GCF of 2. But we said the GCF was 1. This would have a GCF of 2. And vice versa. If this was 20 and that was 2. So I know I can't use that one. Because it would give me a GCF other than 1. And same thing with 4 and 10. They'd have a GCF of 2. So I've eliminated half my choices. So it's either 1 and 40 or 5 and 8. Right? Factors of 6, 1 and 6, 2 and 3. Okay, so I'm going to start with 3x and 2x. And let's try the 5 and the 8. Let's see if that'll work. So we'll do some mental math. Right, little FOIL. That would give us 16. That would give us 15. Can you make 16 and 15 work? Yeah, you can make that equal to 1. So if this was a negative and this was a positive, that would give me negative 1. So we're going to do negative 16x, positive 15x. And if you were to take these two and FOIL it out, right, you would get 6x squared minus 1x minus 40. So that is factored. So this method here, right, takes some getting used to. There's different methods. So if you have a better method, great. The GCF and the guess and check for me works well. But again, I have more experience with it. But understanding the GCF was 1 was very helpful because I eliminated half my choices. Okay, example 2, right? 2 terms. So I'm thinking, okay, GCF. Well, yeah, it's got a GCF of 4. So factor out of 4, so this would give me x squared minus 1. Okay, well, x squared minus 1 is a difference of perfect squares. So once you factor, you always want to double check. Can you factor any further? So that's the difference of perfect squares. So two binomials, plus, minus, or minus plus, doesn't matter. What number or what letter do you square to get x squared? X. What do you square to get 1? 1. So yeah, there you go. That's completely factored. Okay. 3 terms. So is there a GCF? Okay, well, I noticed that they're all divisible by 3. Right, so if I factor out a 3, I have x squared minus 2x minus 15. Well, that makes it a little nicer. So if that's going to factor, it's got to be 2 binomials. So the only way to get x squared is x and x. Okay, multiples of 15, 1 and 15, 3 and 5. Okay, so let's see, 3 and 5, is that going to work? So 3x, 5x. Yeah, I can get, with 3 and 5, can you get 2? Yeah. So negative 5, positive 3. So there you go, completely factored. So understanding the signs here were helpful as well. Right, that helps you determine these signs. Okay, so trinomial, always want to check the GCF. In this case, it's 1. So if it's going to factor, it's going to be 2 binomials. Good thing is 3 is prime. Prime numbers are great when it comes to having to factor because their only product is 1 and itself. So this is 3x, 1x. Okay, 6 is 1 and 6, 2 and 3. Okay, now, again, understanding the GCF is 3, no, that means I know for a fact that's wrong. I don't have to worry about the signs because this would be a GCF of 3. We said the GCF is 1. So I know for a fact the 3 can't go there. So the 3 would have to go here and the 2 would have to go there. And then I do the O and the I basically, right? This would be 9x. This would be 2x. Can 9 and 2 make 7? Yes, it can. Positive 9 minus 2. So plus, minus. And there we go. There's my factoring. So understanding the GCF is very helpful for factoring. Okay, last one here. Right, GCF of 1. So if it does factor, it's going to be 2 binomials. Again, the only way to get 2 is 1 and 2. Multiples of 15, and 1 and 15, 3 and 5. So let's try 5 and let's try 3. So 5x, 6x. Will that give me 1? Can 6 and 5 make 1? Yes. It's got to be a negative 1, so minus plus. Minus plus. And there we go. So the trinomial factoring really helps when you know the GCF. It makes it a little easier. It helps when those A values are nice, like prime numbers. It makes the factoring a little easier. So again, as you go through and factor, right, look at how many terms you have. But you always want to think of trying to do a GCF because it just makes the factoring easier for you. Please make sure